So in this part of the lab, we are going to talk about how to run a logistic regression model using the complex survey dataset. So we are again going to continue from our previous lab 4C, and at the very end of that lab C, we saved the design that we have created in the previous lab, and then also the dataset one with the missing objects or the values, and another is the complete case analysis. But essentially we are going to use the object that we have already created by calculating the weights appropriately, right? Okay. All right, so in this lab 4D, what we are going to use is we are essentially going to use the same design that we have used or created before using the weights. And previously we have seen how to use the GLM function to run the logistic regression, but in here we are going to use a survey GLM function instead of a regular GLM function, and the survey GLM function is within the survey package, and we simply need to specify the design, not the data, because we are not dealing with data anymore. We're dealing with the design that incorporates the weights. And then we specify binomial logic to mean that we are working with a logistic regression, and we specify the formula. This is a very crude analysis, and using the published package we are getting the odds ratio of 4.5. We can also do a multivariate analysis. Only thing you need to change is change the formula. We again run the survey GLM in a similar way, and that gives you all of the odds ratio using the published package. All right. For the model assessment, say for example when you are fitting a logistic regression model, then you can use the AIC or the pseudo R-square values that are more appropriate for the survey data analysis. One point I just want to make quickly is that whenever you are using quasi-binomial instead of binomial, the published package will not work. So make sure that you are using binomial in the family to for the published package to work. All right. So there are a couple of different versions of R-square, pseudo R-square, that are used for survey data analysis, and this is one of them. And in R you can call them using the PS RSQ function, and that can also give you other versions of the pseudo R-squares as well, right? So pseudo R-squares are basically the model used for model assessment fit. So in the next part we are going to talk about backward elimination. So at first we can think about the likelihood ratio approximation and world test, and to conduct a world test you can simply use the reg term test. In the fit 3 we are just trying to see whether BMI coefficient is useful at all or not. So what was our fit 3? Let me go back to the formula 1 that was used to create the fit 3. So in here, see, BMI was one of the variables that we have used, and we just want to see whether that BMI variable is contributing to the regression or not, right? We're essentially trying to see whether the coefficient of BMI category is equal to 0 or not, and we are getting a p-value that is high, right? That means that this BMI category is probably not adding too much in the model. You can also do the same using the update function of the fit 3. So remember, in the fit 3 originally we had the BMI variable. Now let us fit another regression model without the BMI variable using the update function, right? And then when you check the ANOVA using those two nested models, because now fit 4 is a nested model of fit 3, because all the variables are the same, only one variable is excluded, and that's why we call it a nested model. And then we can use the ANOVA to see whether this BMI variable is useful or not, and we are essentially getting a very similar p-value compared to what we were getting using the world test. We can also check the AIC of this fit 3 and fit 4. So we generally prefer the AI model with minimum AIC or lower AIC, right? So when we compare these two models, you see that this fit 4 is associated with minimum AIC. That means, what is fit 4? Fit 4 is just the fit 3, but we do not have BMI anymore. So that gives us a justification to not include BMI in our model anymore. Alright, so let me try to use some of the automated process. Instead of going through this manual process, let me show you some process where you can automate this AIC based selection, similar to the AIC based selection or the stepwise method that you perform in the regular logistic regression. So in here, similar to the regular case, you have a formula with only 3 variables, and you have a survey design package object, and you are using a survey GLM to feed the regression that is suitable for survey dataset. And we are again using the step AIC, and we are using this fit, and we are saying the direction is backward, right? We do the backward illumination, and it does all sorts of check. And see, this is when it is deleting only X. This is the AIC for when it is deleting only the sex variable. This is when it is deleting only the OA variable. This is when it is deleting only the age variable. All of these are higher than the original model that we had. So deleting is not really achieving anything, right? So you see in the when we publish the fit, we see all of these OA, age and sex variables that were originally added, none of them are deleted according to the AIC criterion. Alright, but generally that kind of AIC is not something we encourage you to use. We always encourage you to use keep some of the variables that are important, that you know from your subject area expertise, and then you add the full model where you also add some other variable that about which you are not really sure whether those variables have any value in improving the model or not, right? So you can use this scope object within the step function, where you specify the scope, and if you want to get a AIC, you specify k equals to 2, and that will give you a AIC fit. And after fitting, there were a couple of variables we were checking: doctor, stress, smoke, drink, province, immigrant. So doctor, stress, smoke, drink are there. I do not see province variable here. So you see some of the variables are getting deleted using the AIC. But in our model, we did not really have any interaction term, right? So how do we assess whether we want to include an interaction term or not? So this was our final model from the stepwise regression using the AIC criterion, and we want to just check whether age and sex variable is useful or not. And when we included the interaction of age and sex and we check the ANOVA, we see the p-value is very low, so we keep the interaction in the model. When we add another interaction in the fit AIC, see, we are not using this fit 8a where we already have an interaction. This is a fresh model based on the last main effect term model that we have. We are just checking one by one whether these interactions are useful or not. And then I am using the sex and diabetes as another interaction, and I'm testing using the ANOVA, and this ANOVA p-value is very high, so I'm not going to keep that value. Again, I'm doing another test within using the BMI and diabetes, and then the p-value from the ANOVA is coming out to be low, so I'm going to keep that 2 interactions. So this interaction I keep, this interaction I keep, so the age and sex and the BMI and diabetes. So this age and sex and BMI and diabetes variables should be included in the original fit step fit where we had only the main effect terms. And if you are using this interaction terms to define the interaction, then use the JTools package and use the sum function to get your interactions. And see, the interactions are in here, just the multiplication of the sex and female. So these are not really the directly odds ratio. These are basically the coefficients that you are getting. To get the original coefficients in terms of the odds ratio, exponentiation of your coefficients, you need to define the model using these dot signs, not the interaction function. And then you can use the publish package to see within the age group this, what was the difference between male and female, and what was the exact odds ratio. So it automatically calculates you all the odds ratio. It does not give you the beta coefficient like this in here. And we are just going to save some of the model formulas for later use, and we save this dataset from this so that we can work with this particular model that we have built here and check some of the additional characteristics of this model in the next few labs.